Hello everyone, welcome to Easy Explanation. In this video tutorial we will be learning about dynamic memory allocation using new and delete operator. So there are two ways by which you can allocate memory of a variable or an array. So one is static memory allocation and another is dynamic memory allocation. Now in order to understand dynamic memory allocation, let us discuss about what is static memory allocation. So static memory allocation is allocation of a memory of a variable or an array during compile time. So compile time allocation of a memory is called as static memory allocation. So generally let us say simply I have written a code something like this: int main, now int a is equals to 10 and cout a is equals to a and return 0. So in this case the memory for a variable a is allocated during the compile time by a compiler. So before execution of this code the memory of the variable a is allocated. So this is the example of a static memory allocation. Now whenever you are allocating the memory of a variable or an array during the execution of a program, it is called as a dynamic memory allocation. So dynamic memory allocation is also called as runtime memory allocation. So dynamic memory allocation is also called as runtime memory allocation. So it is nothing but the allocation of a memory of a variable or an array during the execution of program. So runtime memory allocation. So in C++ programming language we can allocate as well as deallocate the dynamically allocated memory by using new and delete operator. So in C++ we can allocate and deallocate the memory of a variable or an array using new and delete operator respectively. It means you can dynamically allocate the memory using new operator and dynamically deallocate the memory using delete operator. So once the memory is allocated for a variable or an array dynamically, then we need to manually deallocate the memory allocated for those variables by using the delete operator. So let us use this new and delete operator to allocate the memory and deallocate the memory. So dynamic memory allocation is done by using new and deallocation is done by using delete operator. So let us write a simple code to understand the concept. For that I have created a file called as dynamic mem.cpp and then let's start writing the code in order to understand the concept. So as include stream using name space std int main, now int a is equals to 10 cout a is equals to a and l and simply return 0. In this case memory for the variable a is allocated during compile time only. So in this scenario it is a static memory allocation. So let us understand this. So no memory allocated during the runtime. So this is the case of a static memory allocation. Now let us allocate a memory for this variable a in the runtime by using new operator and deallocate that using delete operator. So for that, what you have to do is, let us write a simple program for that. For that, first we'll be creating a pointer variable int star ptr. So it is nothing but a pointer variable, and ptr is equals to new int. Here the new operator returns the address of a allocated memory, dynamically allocated memory, and assign it to a pointer variable ptr. So whenever you do something like this, int star ptr, ptr is equals to new int. So this new operator will help you to dynamically allocate the memory. Let us say I have allocated a memory of size int, size of int size of memory is allocated. Now obviously when the memory is allocated, some dynamic address will also be generated. Now this address is assigned into pointer variable ptr. Now pointer variable ptr contains the address 10200. So this is ptr variable. It contains address of newly allocated memory, which is 10200. Now at this location we need to assign some value. Now we can assign this value by using something like this, star ptr is equals to 20. Whenever we do this, so star ptr is equals to 20 means at the location stored in ptr store the value 20. So here 20 is stored. Now you can print or perform whatever operation you want on the variable ptr or the value located in the pointer variable ptr. So the value of a is equals to, then write star ptr and l. Now so after doing the operation on the ptr variable, the variable goes out of scope, means there is no use of variable now after this line number 9. So once the use of the variable is done, what you can do is you can deallocate the memory that you have dynamically allocated. So now deallocation is done by using this delete operator. So delete ptr. So delete ptr is used to deallocate dynamically allocated memory. So in this case, dynamically allocate the memory. Now when we perform the operation, compile and run the code, so we have invalid operand types constant char 18 int into binary operator, this it is saying. So what I'll do is, so I think I've made some mistake here, invalid operand types. So this operator is missing over here. Now run the code again. Now you can see we have got the output as the value of a is equals to 20. So this is the case of dynamic memory allocation. In this case, memory is allocated for a variable dynamically during the runtime of a program. So this is the example of dynamic memory allocation using new operator and deallocation using the delete operator. Now let us perform the same operation. Let's perform the same operation for an array. So for that I'll be creating a new file, new source file, save as, so array underscore array underscore dynamic underscore mem dot cpp. Again, include the required header files as include io stream using name space std int main. Again, since the new operator always returns the address of a variable, address of dynamically allocated memory, so for that we need to, every time we need to use a pointer variable. So I'll be using ptr only, star ptr. Now ptr is equals to new int of some size, that means how much memory size you want to allocate. For that, what we will do is star ptr comma size. Let us say I'm writing a program that will store marks obtained by 10 student or 5 student in a class. So cout enter number of students, then cin size. Then what you can do is new int of size. So this is the case of dynamic memory allocation. So in the runtime you are asking the user to enter the size, and in the runtime what we are doing is we are allocating the required size of memory. So this is not like in C programming language, whenever you allocate the memory by using this operation or by using this syntax int a of 20, then in compile time 20 into size of int byte of memory allocated during the compile time. So we can change this scenario by using the new operator in which we are dynamically allocating the memory. So we can allocate the memory of whatever size we want in the runtime also by using this new operator. So that is the advantage of using new or dynamic memory allocation over the static memory allocation. Now new int of size. Now let us add some values into the array that we have created. Now cout enter marks of size students. So for that, for I is equals to 0, I less than size, I plus plus, and then what we can do is cin star ptr plus I. So this is the simple pointer operation, and what we can do is I plus plus is already done. So this will help you to assign the value at the location that we have dynamically allocated, and finally what we can do is we can print the values at those locations. For that I'll be copying this only, Control B, following are marks obtained by size students. Cout star ptr plus I cout in L, and I think the pointer is not required here. Okay, it is needed. star ptr plus I. Now whenever you run this code, enter number of student 5, enter the mark of 5 students, 20, 30, 40, 50, 60, and you can see marks obtained by 5 students are 20, 30, 40, 50 and 60. And let us say I'm using /t to provide some tab spaces between the results. Number of student, let us say now number of student is 10, so enter the values 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. You can see the following are the marks obtained by 10 students, which are 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. So this is the case of dynamic memory allocation. So we can allocate whatever the size of memory we require during the runtime by using the concept of new, and in this case we have allocated the memory for the variable, but we do not have deallocated the allocated memory. So we can deallocate the allocated memory by using delete, and in order to deallocate the values of an array or memory allocated for the array, we have to use this operator and then use the pointer name delete ptr. Now enter the memory number of student 3, 10, 20, 30, marks obtained by 3 students 10, 20, 30. So whenever the variable goes out of scope, you can deallocate the variable by using this delete operator. So finally return 0. Now this is the whole code. So you can see here, in this way we can perform dynamic memory allocation. So this is the case of dynamic memory allocation using new operator, and whenever the variable array or ptr variable goes out of scope, you can deallocate the array by using this delete operator, deallocate memory. So everything is performed during the runtime. So this is the example of dynamic memory allocation using new and deallocation using delete operator. So please look at the code. So this is for the array variable and this is for the normal variable. So the other uses of new operator is for creating the object in the runtime. So we will be learning this concept in class, in the concept of class and object, or while I will be discussing the concept of class and object. So that is all about the dynamic memory allocation using new and delete operator. Thank you so much everyone. If you have any queries regarding this, if you have any queries or doubt regarding this concept, please let us know through the message. Thank you so much everyone for listening. Bye bye.